Wow, look, there's even
Yeah, we can do it like that.
there you go.
All right, so hello everyone. My name's Adrian, and I'm a DevOps engineer, or how I prefer to call myself, a net DevOps engineer at Codaline.
And I'm Adam Baumeister. I'm a global solutions architect for Palo Alto Networks. And despite the title, I do actually do some work.
So, as presentation's title suggests, we are going to talk about an Ansible-based automation solution for mass firewall upgrades. And it will be based on a real customer case study. It's a case study, so it's going to be pretty practical, but we are also going to touch like a business perspective side of things, so I hope you find it interesting. Oh, we have no clicker.
I think it's just there.
Realized. All right. Okay, so we wanted to share a real customer story with you, quite recent, where a challenging project turned into a remarkable success. Sorry, not sorry. And what's best about it is that all the effort put into this project got transformed into a complete reusable solution that can be offered in a service manner, and we are actually offering as a service to the customers. I'll tell you something about the task itself. So in the dynamic landscape of cybersecurity, it's crucial, it's essential to stay up to date with the latest security updates, software releases, with new features, with enhancement. It's a necessity in nowadays security world. And our customer had a large number of firewalls, and firewalls of different kinds. It was physical, virtual, it was on premises and in the clouds. It was HA pairs and standalone firewalls. It was on different software versions and in different software branches. So yeah, plenty of that. And all of that summed up to more than 500 nodes. We also had to ensure that the upgrades won't do much harm to the working environment. Of course, to the extent possible, they will not interrupt network connectivity or diminish the security posture. All right, so the customer was from the healthcare industry, and that means the centralized structure with hundreds of branches and locations dispersed geographically throughout the United States. Yeah, hence the great number of firewalls and large variety of platforms. This type of customers tends to value security and understand the importance of frequent firewall upgrades, so that's great. So let's talk about the challenges that we identified, challenges to manual delivery that we identified in the planning phase of the project. First of all is, of course, the volume. Single firewall upgrade can take up to 20, 30 minutes, and in conjunction with comprehensive testing to make sure that the upgrade didn't cause any issues to the environment, it can take about an hour or even more. Now repeat that 500 times. Different platforms, different software versions, different configurations, all of that makes it almost impossible to test every single upgrade scenario in the lab beforehand. Even if we did very extensive testing in the lab in order to catch any potential issues early, it would be, and if we engage multiple engineers in order to deliver and perform the upgrades in parallel, we would need to repeat this gigantic effort in a couple of months, basically. So that would be a huge waste of human resource. Second challenge is related to the specifics of the customer business. Yeah, most of the customers' facilities operate 24 hours a day, every single day of the week. And in such environments, as you all pretty know, there is little time for downtime and extremely low tolerance for failure. Also, a situation where an engineer is performing an upgrade and he doesn't spot an issue during the testing phase that might cause some problems at a later stage was an evident risk. So there was also was always related to manual operations, the human error factor. So all of that led us to an obvious decision on automated approach. And what was the reasoning for that? First of all, it's the high pace of upgrades, thanks to getting rid of manual inputs and the ability to run the scripts against multiple firewalls at the same time. Second of all is automated verification steps, automated testing before and after the upgrade. And third is the consistency of the process, of course, because we are eliminating the human factor error that I just mentioned. And finally is the reusability of the solution for any future mass firewall upgrade activities. So we are future-proofing the customer by giving him the solution. All those arguments convinced our customer and boosted his confidence in the overall project success. Okay, now I'm handing over to Adam, who's going to tell you about the technical functionalities required by the customer.
Thanks, Adrian. Yeah, so pretty much exactly as Adrian just mentioned, we've just gone through basically the business requirements that we got from this particular customer. I think we're all familiar with gathering business requirements, and then hopefully we're all also familiar with turning them into technical requirements. So that's what I'm going to go through now. Thanks. So the number one requirement we had from this customer, very, very common requirement. Most of our customers, our Palo Alto Networks customers, they're running high availability. So we need to be able to support that in an automated way. So we don't want to have any manual intervention when we're dealing with high availability configurations, regardless of what sort of HA config the customer is actually using. Most of our customers are relatively sane, and they use active-passive. But we do have a lot of those out there also using active-active. And we even have some customers, a growing number of customers, to be honest, that are using cloud-based load balancer sandwich style deployments, which have effectively arbitrary pools of high availability firewalls. So we need to be able to automate all of those, right? So we're trying to design automation that can handle all those different use cases. The other big thing that we need to look after is our different hardware platforms. Whenever you write code, I think we all know it's easy to write code in a lab against, in our case, we write a lot of code against virtual machines, like VM series firewalls. It works. You say, yeah, perfect, job done, that was easy. Then you go to actually run it against a real firewall, especially some of our smaller firewalls, like the 220 series, or some of our larger firewalls in some cases, and it breaks, and you have customers screaming at you. And it's like, well, that's something that we also have to handle. So we have to make sure that we support every type of hardware platform that we have available, and hopefully that we have in the future as well. So Adrian mentioned a big part of this customer, and to be honest, virtually every customer that we've ever dealt with, certainly every customer I've ever dealt with, testing firewall upgrades is a really big problem. A lot of people don't do it. A lot of people just close their eyes and do the reboot and pray, essentially, But in this case, certainly with this customer, a big healthcare customer, doesn't really work, doesn't suit. So we want to implement a variety of tests to basically make that suitable. So the very first type of test that we implemented is what we call readiness checks or readiness tests. These tests effectively basically just to validate that the firewall is capable of being upgraded. The best way to describe that is we had another customer, separate to this one, to this use case, who had booked an outage. They'd gone through the process of booking, going through change control, all of our favorite things, months in advance, which we all do, right? Everybody does that, right? Months in advance, prepared to upgrade their data center firewalls. They waited the months to be able to get the window. The business had lined up all the stakeholders. They came to do the upgrade, and they found that high availability wasn't functional. One of the devices was effectively in a non-functional state, had to back out. Of course, they couldn't upgrade the device, and they had to back out the entire change, wait another 3 months, and then go ahead and do it again. Huge waste of time, resources, and of course, a lot of boredom. So readiness tests are basically designed to make sure that never happens. So readiness checks, we have a whole suite of them that are available online if you want to see the whole list of them. We'll talk a little bit more how they're packaged later. But essentially, we do things like we check HA status, like I just mentioned there. We also look for things like valid licenses, the fact that they're connected to our central management platform, Panorama. Also other minor things like there's enough disk space to actually fit the latest software on to be able to upgrade. We do all these things before we start the upgrade process, and I'll talk about the upgrade process a little later on as well. But the key thing here, while we're talking firewall upgrades today, none of these tests, like everybody here I'm sure has noticed, none of these tests are specific to an upgrade process, right? So a lot of customers come to me and they say, well, you've got this test suite. Do we have to run it as part of the upgrade process? And the answer is no, of course you don't. So we've got customers out there that are basically running these periodically, sending it to Grafana or Prometheus or whatever. Perfectly viable use case. And it's just a nice way to make sure, in our case, that the firewalls are running properly. So I'm going to hand it back to Adrian to talk to our other type of test, which we call comparison or snapshot tests. Yes, sir?
All right, so snapshot or comparison tests, as we call them, are designed to make the firewalls, like make sure that the firewalls come back to the state after the upgrade to the same state as it was originally. So how it's achieved? We take the most important runtime information from the firewall, we take a snapshot of it, and we do it before and after the upgrade, and in the end, we compare the two. Yeah, simple as that. Then, maybe on a lower level, how we do it is that we developed a Python library that queries the firewall's API, XML API. And yeah, it queries for information like, among others, NIC status, ARP table entries, root or forwarding table entries, BGP peer state, or tunnel state, like IPsec, GRE tunnels, and that kind of stuff. And all of that information in this snapshot are stored in a JSON format. I wanted to emphasize that all of the tests, the snapshot data collection we talk about are based on the lessons learned in the field, because we've seen a lot of unusual behaviors after upgrades. And I'll share a customer example with you. So the customer upgraded, and thanks to comparison tests, he found out that all of the next hop IP addresses in the root table have changed. I think it was related to some BGP issue in the software release that prevented the neighborship to establish. But anyway, without automation, it may not have been picked up until it was too late. Next, one more important thing to mention when we talk about comparison tests is the comparison test failure condition. Because it's not like Boolean value, true or false. Most of them needs to be configurable, and we need to adjust them to customer-specific needs or specifics of his environment. Let's take ARP table for instance, right? So we have some ARP table, and we need to decide on how many ARP entries can we lose before it becomes a problem. Because maybe if we lose like 10 or 20% of ARP entries, we don't consider this a problem, and we treat it as a normal behavior. Or referencing to the customer example I gave you, maybe you don't actually care if the next hop IP addresses in the root table changed, because you have multiple neighbors that can pick up this traffic and forward it, right? So we need to parameterize the comparison tests. Yeah, summing up, we talk a lot about testing, me and Adam here, right? Readiness checks, comparison tests, a lot of time. Why? Because we think this is actually the crucial part, the most crucial part here. We consider this the main feature of the solution and the main selling point of the solution. Because, let's admit it, right? The firewall upgrade itself, it's not that hard, right? You can trigger this manually, you can trigger it in an automated way, it can be scheduled and stuff, but it's the testing that is the hardest part, and it's the most time-consuming part. We think that the testing is the operation, like in the entire software upgrade process, is the operation that takes the majority of engineers' operational time when performing an upgrade. And yeah, that's why we put such big focus on it. Okay, backup and rollback. So the customer obviously wanted to have an assurance that if he needs to roll back, he can do it quickly and efficiently. The trigger, I mean, the rollback can be triggered manually, And that's what our customer actually wanted in that case. He wanted to make a fully conscious decision whether he needs to roll back or not, based off the post-upgrade report, which I'll talk about in a minute. But it's fairly easy to implement a automatically triggered rollback on failure of basically any check. When we talk about rollbacks, it's also important to mention the test suite. All the tests, all the readiness checks, all the comparison tests, they also should run after the rollback, because it may happen that something is still wrong after we roll back, like the HA is not coming back to a functional state, or routing is not reconverging. So that's very important. And yeah, another safety mechanism that we implemented in the final solution was the collection of a fresh configuration backups, as well as tech support files, which contain even more useful information about the firewall itself, which can be pretty handy when we are troubleshooting. For example, if we roll back and the network doesn't work. And finally, the post-upgrade reports. If the firewall upgrade goes smoothly, a prompt in the terminal window might probably be enough, right? However, if anything goes wrong, we need to show the problem to the user in a most friendly and lucid form possible. What we are doing, we are generating an HTML report for each firewall or firewall pair, and it contains all the information about the tests we did, about the upgrade itself. It's just all the results, all the information that the customer might need to decide whether the upgrade was successful or maybe he needs to roll back. For comparison tests, what is actually very useful, that it will actually show you a diff between the pre-upgrade firewall state and the post-upgrade firewall state. Okay, passing back to Adam, who will talk about the components of the solution themselves.
Exactly. Thanks, Adrian. Yeah, so we talked about the business requirements and we talked about the technical requirements. Now it's time to talk about what we actually built, right? So what we actually did. To set the stage a little bit, you're going to hear me use the word "you could do this" or "maybe you could do this" a lot. It's because ultimately what we're out to build is something that's very modular and reusable, right? So it's not me just saying, oh, theoretically you could do this. That's the way it was designed, essentially. So this is the actual flow. This is the entire end-to-end automation flow. It's pretty simple because upgrading firewalls as a process is relatively simple. As Adrian mentioned, the value in automating it is the value of the tests and the repeatability and the reusability effectively. So starting right from the left, the user starts the upgrade process. Now that's based on their automation platform of choice. We like Ansible here. I've come to learn that apparently Ansible is not cool anymore. Someone shout out a cool automation platform. Is there a cool one? Yeah, Naughty. All right, I'll take Naughty. Yeah, fair enough. So there you go. So we like Ansible. Everything is written in Python. Ansible is kind of our first-class citizen, we'd say, but I'll talk a little bit more about the way that it's platformed later on. So the user starts the upgrade. The very first thing that happens is the readiness test suite runs to make sure that the firewalls, whether it's one, whether it's a HA pair, whether it's 100 firewalls, are validated to make sure that the upgrade process can actually proceed. Assuming that's all green, and yes, of course, it passes all those tests, or if anything is red and the user just chooses to ignore the failed test, that happens. Perfectly reasonable, I guess. Why have a test suite? Readiness checks, assuming all that passes, the next thing that happens is we take what we call a pre-upgrade snapshot. So we talked about snapshot comparison tests earlier. This is where we take the first picture of that data to be later used. Just as with the readiness checks, you can do that on a scheduled basis if you prefer. So I had a customer just the other day ask me whether they could just run a cron job effectively to take the snapshot of the data every 5 minutes. Absolutely no reason to. At a technical level, it's effectively just a series of show commands, and then it's converted into tabular data so that we can make logical comparisons against it. After all that's done, we go ahead and actually start the upgrade itself, represented, there's obviously a lot of logic represented by that one small circle in the middle there, but that's where we manage our high availability settings, our failovers, our installs and reboots, and basically everything else that's involved in making sure that either a single, a pair, or pool of firewalls will come back to a rebooted state in on the new software version. After that's done, we go ahead and do what we call the post-upgrade checks. Effectively, the post-upgrade checks are just the readiness checks again to make sure that none of those have changed either. So a common, probably the most obvious example of that would be you've upgraded a HA pair and now the HA status didn't come back to functional. Of course, that's a test you want to rerun, but it's not really a comparison, so it's slightly different. At the same time, we also take the post-upgrade snapshot. So we run all those show commands again, generate that same tabular data. From there, we can do the comparison tests or run through the comparison test suite to make sure things like the routing table is back to the same state, the ARC table hasn't lost too many entries, the session count hasn't deviated too much from a kind of a norm. And assuming all of that stuff passes, we can finally end with a true, essentially a Boolean, you passed or you failed. Now, of course, you can dig as deep as you would like into the data, so you've got, which you'll see later when we show a report, but effectively, like with most automation, it's most useful to be able to say, it worked, it didn't work, and then from there you can branch additional logic if you'd like to. After we do all that, we of course generate a report for the users so they can visualize the results. Most customers want that. Some customers just want to store it as JSON. Of course, they don't really care about a HTML report, but of course we do it by kind of default. So when we set out to design, when we did design this solution, we really didn't want to write a whole bunch of code, or we didn't want to duplicate stuff that was already out there. And like I mentioned before, we want to make it modular, right? So we use the Python SDK for the vast majority of the kind of the heavyweight automation bits. So Panos Python, we leverage heavily. Obviously, we're heavily contributors to that project. And of course, we use Ansible Galaxy, or our Ansible Galaxy collection is our first-class kind of consumer of all of the automation that we've produced here. So with a combination of those two things, our Panos Python SDK is, of course, an open source, and it's based on the XML API. We like to think that it's very reusable, it's very reliable, it's a very commonly used support model as well. In addition to the SDK in our Ansible Galaxy collection, we also had to go out and actually write the test suite, right? The big thing with the test framework is that we wanted to essentially build in our own internally learned methodologies for upgrading customer firewalls directly into the code itself. So there's a bit of value for automation that maybe sometimes people don't really think about, but we as engineers, everybody here is an engineer, we do a lot of things, whether it's manually or in an automated way, where the reason we do them, if there is one sometimes, is in our heads, right? If you can convert the actual reasoning into code, that's a really big bonus. That's what we've tried to do with the actual test framework as well. It follows the exact same philosophy as well. So of course, we're using the Panos Python SDK right underneath, and then we layered another Python library on top of that we've written. So there's a maximum amount of code reuse, basically. Everything is available. It's all open source. It's available on PyPy and on GitHub, of course. And ultimately, the goal here is to be as low friction as possible. We didn't want our customers or our users having to install anything really heavyweight, having to pull non-open source stuff or package stuff. We just want them to be able to install straight from GitHub or PyPy, essentially. We also, to sort of build all this together, because obviously I'm talking a lot about modular components and we've got this piece and this piece, to tie it all together, like I said before, we essentially use Ansible playbooks on a per customer basis, right? So we're out there building playbooks. Yeah, we might have some generic ones available, but our customers come to us because they want us to tailor a solution for them. So all we're essentially doing is stitching all the different modular components together into a process that works for them. Another great thing about the Ansible playbook sort of model is that we can customize it further for the customer based on maybe they want to trigger it from an ITSM, or maybe they want to use a different platform, or they want to leverage any other power of Ansible, essentially. Ansible playbooks, of course, do the entire orchestration of the entire process. That means that not only does it run the tests and do all the failover and the upgrade process, it also is the thing responsible for generating the reports. Again, if you want to lean heavily or more heavily on Ansible itself, you could take those reports, put them in an ITSM, store them in a relational database, or just email them to somebody if you wanted to. Again, these are all kind of the benefits we see from using Ansible. You can, of course, do all this within Python as well if you prefer. This is an example of us running a generic one. I think everybody's seen an Ansible playbook execution, so it's probably not that exciting, just to show that it does work. Technically, I could have just mocked this stuff, I guess, but it did work. The big thing I wanted to show here, or the big thing I wanted to say here, of course, this is just running it from the CLI. We do support AWX as well. Of course, everybody knows essentially it's just Ansible playbooks just with the UI laid on top, which is very useful. So of course, we support that natively as well. So we do have some customers using AWX and they want to use it that way. So Adrian, could you
I'll
come
do you a
on?
favor. Yeah.
Thank you. So this is an example of the actual upgrade or the report at the end of the day that you get after the process is finished for a firewall pair. The reason we're showing you this is basically to give you a better idea of what actually like the tests kind of look like. Forgive our HTML. We're not front-end developers here. Not that you could tell, right? It looks so good. Thank you. Yeah, so in this case, we've run it against a pair of firewalls, and we can see that a couple of tests here have failed. So we've got data plane NIC status and route status is showing up as not okay. Like Adrian mentioned before, and like I mentioned earlier as well, the key thing is that ultimately we're trying to build modular components, and like I said, the easiest way to build a test suite is ultimately to have a pass or a fail at the end of the day. So that's kind of a core part of the philosophy or the design of this particular code. So here you can see that those failures, you can see that NICs have failed because they've gone from up to down, and you can see that the routing table has failed because we've lost a lot of routes out of the routing table. As mentioned earlier, we don't just check for lost routes, of course. Basically, everything that is useful that we use as part of our methodologies for testing, we try to implement them in the tests themselves as well. To use a quick other example, one time I was with a customer and I was doing a test that was based on the ARP table. This is a long time ago. I had upgraded the software, and what I didn't notice was that 300 entries in the ARP table, the MAC addresses had changed. So everything else was the same, but the MAC addresses had changed. And didn't think much of it at the time, because to be honest, I didn't notice it because I hadn't automated the testing of it. I just glanced at it, didn't notice, away you go. This is 30,000 ARP entries, so I think I'm not going to be too hard on myself. It turned out it was 300 of the most critical pieces of infrastructure in the network. So it caused a huge issue, got yelled at, had to roll back. With our test suite, would have noticed it immediately. So would have spotted it within 2 seconds, and I could have rolled back and not get yelled at, which would have been nice.
Okay, coming back to the PPT.
Okay. Adrian is going to talk now about the actual results of this use case.
All right, thank you, Adam. So, how did all of that actually end? I'm going to repeat myself here, but we developed a reusable end-to-end solution using open source components only, and we tailored it to customer-specific needs. Second of all, we checked all the project's deliverables in a timely manner and with incredible high quality. Not to brag about it. And yeah, we hit an amazing milestone of 100 firewalls upgraded over a single maintenance window. I think that we developed something that is very easy to use, because after a first session, we were able to hand over the scripts to the network operations team, and they were able to carry on with the upgrades afterwards. And finally, this venture opened us a door to deliver similar projects with the software, and we are constantly working on improving the solution. Thank you very much. I think that's it. I hope you found it insightful.
Thanks, everybody.
Hope this was an inspiring story to some of you. Adam, would you like to add something?
No, I was going to open it up for questions. There's a couple back there.
Awesome. Questions?
There's one at the back there as well.
Well, thank you for the presentation. It was very nice. My question would be, if during this whole process, you mentioned that you're using Python at some point, you're using Ansible to orchestrate. What makes to you the decision between develop part of this process in Python or in Ansible? For example, if there is a module that does that already in Ansible natively, but there is also a Python, let's say, library or API that you can use, what leads the decision in using it natively in Ansible or going with a Python script that is orchestrated by Ansible?
Yes, so that's a really good question. To be honest, most of the time the answer is it's based on what the customer wants. So from a high level, from like a code architecture standpoint, everything is modular at a Python level. So of course, the actual functions, so for example, every one of our readiness tests or our snapshot comparison tests, the actual snapshot process itself, all of that is made available to Ansible as individual Ansible modules, right? So it's kind of a best of both worlds there, right? But to further to your question, whether or not like on a per customer basis, essentially we would use Python versus just like do everything in Python versus doing it within Ansible. If the customer just wants to bundle the entire process together in one script, like a one-shot script, we'd probably lean more on the Python way. If, however, they're either already an Ansible user, which to be honest, a lot of our customers are, then of course we'll do the Ansible-based deployment. And from a more philosophical perspective, it's kind of, generally, we see it as being slightly more maintainable given that we're trying to hand the code over to use Ansible, like to use playbooks and to stitch things together as more modular components, literally Ansible tasks, rather than trying to build a very heavyweight, Python script, even if ultimately that script is just running within Ansible. Does that make sense? Does that answer your question? Thank you.
All right, more questions?
Cool. My question.
Back there.
We got second question here.
Oh, sorry, mate.
No worries, no worries.
First row, it's let's you see.
Just go straight over here. Yeah.
I'm curious about the success rate of the upgrades, and would you ever consider running them unmanned? So just schedule them, go to sleep, and we see in the morning what happened.
Excellent question.
Thank you.
I might answer on that. I think that's what a lot of people do when they are very confident, but I wouldn't think that that's actually a good approach, because you want to see the results. You want to see the results right after you upgrade, and you need to know whether you want to roll back or maybe not. If you automate the rollbacks as well, and you tested it because your environment is pretty monolithic and it's like all environments are identical, you can maybe predict what will be the result because you did it so many times. But if the case is like with our customers, that they have so many platforms, so many configurations, so many different versions, it's really difficult to predict the result from the top of your head. And it was also really difficult to parameterize the rollback trigger, because they didn't really know what problems they might encounter and how to program the automatic rollback. So they wanted to upgrade, analyze all the reports, and on the go decide what they want to do next. Are we good, or are we going back? So does that answer your question?
We also had, just to extend to that, we had a customer explicitly ask us to design a solution based on this, essentially using all the code, but a specific solution for them, that effectively you could schedule the upgrades so that they would run unmanned overnight at like 3 in the morning, so they could wake up and then just log in and check to make sure the tests are passed. So we did do that for them. Ultimately, they didn't put it into production because the first time someone, with a C in their title saw it, they went, "What on earth are you doing?" But it's really good use case if you've got like lab environments or staging environments where you don't, if it breaks, it's not the end of the world. For sure, it's absolutely possible. And there's no manual, intervention required if you don't want to.
Yeah, we need to remember that this specific case study was also a customer which had facilities running 24 hours a day, 7 days a week. So there was not really a situation where, okay, we'll just log in at 6 a.m. and and we'll see what happens. It was a working environment all the time. Yeah. So
next question.
Hi. Thank you for this presentation, guys. It was very nice. Yeah, I have a couple questions. Can we expand a little bit more technically? What Ansible models you used? First question. Second, did you create your own Ansible models on Python, for example, if existing models was not achieved? What did you try to achieve? It's not fit what you try to achieve. Second question about inventory. Did you use dynamic or static? If it's dynamic, what source of trust you use it? If it's in static inventory, how you populated it? And what else about Ansible I want to hear? About Python. What multi-threading connection you used? Did you use async mode, or did you use, I know, some multi-threading already ready models? So, and not models, libraries when we're speaking about Python. So
from an Ansible perspective, we did have to write additional modules to support the test suite effectively. We added those as part of our open source Ansible Galaxy collection, which is Palo Alto Networks /panels for anyone that would like to get it. That gives you all of this that we just talked about today. So we did have to do that. We did base those loosely on existing modules that we had. The test suite we had to write from scratch, basically. But they're relatively short Ansible modules, so we did do that. For inventory for this particular customer, we used a static inventory. For other customers, we've used dynamic inventory scripts. Actually forget if there's a new name for them in Ansible. But
the source of truth is basically the central management platform, which is Panorama in that case. So we wrote a script for a recent customer that takes the export of all the inventory from Panorama and transforms it into an Ansible inventory.
Exactly, yeah. It's cool with that as well, because obviously Ansible inventory can be pretty dynamic with how you group things, with the variables you use. That works really well in that case as well. As for asynchronicity, we just use effectively whatever's default with Ansible when we're running it for this particular customer. So obviously Ansible parallelizes things by default or tasks by default.
Yeah.
I don't think we customized it at all. So yeah, I can't really answer that question that well, sorry.
Yeah.
Oh, we're going to cut it there. Thanks, Adam and Adrian.
Thank you very much.
Thanks, guys. Come see us after.
Yeah. One more sentence. I saw some hands up, so if we didn't get to answer all of your questions, you can find us on the vendor area. Come to Cody Lime stage, and we will be happy to answer all of your questions in more details and maybe do a little demo if you like.
Thanks, guys.
Thank you very much.